I thank you all for watching my videos all these years. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the question paper CSIR National Eligibility Test held in the month of June 2023. This question is from the section Real Analysis and it is related to the discussion of continuity of a given function restricted to a given set of sets. This question is from part C, which is a multiple select question. There can be more than one answer, and this question carries 4.75 marks. The question ID is 704064. This question is suitable for all these examinations. Right. The given question is define a function f from the set of real numbers into itself defined by f of x is equal to sine of pi by x when x not equal to 0 and is equal to 0 when x is equal to 0. On which of the following subsets of R the restriction of f is a continuous function? We are given four options. Option 1, closed interval -1 to +1. Option 2, the open interval 0 to 1. Option 3, the singleton 0 union, the set consisting of 1 by n, n belongs to the set of natural numbers. Option 4, the set consisting of 1 by 2 power n, n belongs to the set of natural numbers. So, we are given a function defined like this, and we have to discuss the continuity of this function when restricted to the following subsets. Right? That means we have to talk about the restriction of f to a given set. Let's now discuss the solution of the problem in detail. We have f, a function from the set of real numbers to real numbers defined by f of x is equal to sine of pi by x when x not equal to 0 is equal to 0 when x is equal to 0. The given function is a well-known function and it is continuous everywhere on R except at x is equal to 0. So, now we get familiarized with the definition of restriction function. Let capital X be a subset of R. So, how do we define the restriction of the given function f to capital X? The restriction of f to capital X is the function f restricted to x whose domain is capital X and codomain is R defined by f restricted to capital X of x is equal to f of x for all x belongs to x. F restricted to x of x will be f of x, x belongs to capital X. Agreed. Let's now take up the options one after the other. Option 1, closed interval -1 to +1. Let us call this as the set capital A. Now, the restriction of f to capital A is a function from A to R defined by f restricted to capital A of x is f of x, x belongs to A. That is, this is equal to sin pi by x when x belongs to A, that is the closed interval -1 to +1, x not equal to 0, and is 0 when x is 0. Right? It's again this function defined like this, where this set A is the closed interval -1 to +1 includes 0. Therefore, f restricted to A is continuous everywhere on the closed interval -1 to +1 except at x is equal to 0. It's very clear. So, the restriction of f to capital A, that is closed interval -1 to +1, is not a continuous function. Right. Let us take up option 2. This time the open interval 0 to 1. Let us call this as the set capital B. Now f restricted to B is a map from B to R defined by f restricted to B of x is equal to f of x, x belongs to B. This is equal to sin of pi by x when x belongs to B. B is the open interval 0 to 1 and 0 is not involved here. Therefore, sin pi by x is continuous at every point of the open interval 0 to 1. Therefore, f restricted to B is continuous on B, that is the open interval 0 to 1. Thus, the restriction of f to the open interval 0 to 1 is continuous. So, for option 2, it's okay. Let's move to option 3. This time, the set consisting of 0 union the set of 1 by n, n belongs to n. Let's call this as the set capital C. F restricted to C is a function from C to R defined by f restricted to C of x is f of x, x belongs to C, and that is equal to sin pi by x when x belongs to the set consisting of 1 by n, n belongs to n, and C also has 0, therefore it is 0 when x is 0. When x is 0. Right. In sin pi by x when x belongs to the set consisting of 1 by n, n belongs to n. So wherever there is x, we write 1 by n, that will be sin n pi. So that will be equal to sin n pi when n belongs to the set of natural numbers and 0 when x is equal to 0. What is sin n pi? For all values of the natural numbers, sin n pi is 0. So this is 0 for all x belongs to the C. That means f restricted to C is a constant function and it gives 0 for all x belongs to C. And it is very well known that every continuous function, every constant function is continuous. Yes. So clearly f restricted to C is continuous on C since it is a constant function. Therefore, the restriction of f to C is also continuous. So option 2, option 3 are okay. Option 1 is not okay. Let's move to the last option, option 4. The set consisting of 1 by 2 power n, n belongs to the set of natural numbers. Let us call this as the set capital D. F restricted to capital D is a function from D to R defined by f restricted to D on of x is equal to f of x, x belongs to D is equal to sin of pi by x, x belongs to D is 1 by 2 power n, n belongs to n. So wherever there is x, you write 1 by 2 power n, and that is sin 2 power n into pi, n belongs to n. So when n belongs to n, 2 power n is always even. So the even multiples of pi of sine. Sine of even multiples of pi is always 0 for all x belongs to D. So, f restricted to D is 0 for all x belongs to D, that is, it is a continuous function on D. And every continuous function, it is a constant function. I am sorry, it is a constant function. So, every constant function is a continuous function. Therefore, f restricted to D is continuous since it is a constant function. Agreed. Therefore, the restriction of f to D, where D is the set consisting of 1 by 2 power n, n belongs to n, is continuous. So, there's the options 2, 3 and 4 are true. For option 1, the restriction was not continuous. Right. The answer to this question, options 2, 3 and 4, and that is the detailed discussion of the solution of the problem from real analysis, which is related to the continuity of a given function restricted to given set of domains. Agreed. Agreed. And the question is a very simple and straightforward question. I am sure that you have understood the solution of this problem. Thank you for watching my video now. Please like and share my videos with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Let's hope to meet you once again in another episode of learning. Happy learning. I wish you all the best. Thank you.